Hello guys, welcome back. This is the second part of this lecture about the double pulse test of parallel modules. And this is also the last video of this open course series. At the beginning, I want to answer a question why we use it in parallel as example because it can cover most of cases in industry application. First, in this slide, I listed the important test steps. The general process is quite similar, so get signal consistency of module in parallel, switching characteristics test, current sharing test of IGBT, current sharing test of diode. The two new tests are current sharing test and signal synchronized test. And the other steps are same like normal double pulse test. Let us start from the first step. We will test the consistency of the gate signal first, which can also be named as VGE consistency test. Go to next slide. This is one half bridge here in this slide from parallel modules. We will keep Q2 always be off and test the gate voltage VGE of 6Q1 during the double pulse test, because now we have 6 modules in parallel operation. Depends on your using oscilloscope. At the same time, we can measure the corresponding current and VCE voltage. Then conduct the test as usual and record the waveform. Before we read the data, we can merge the waveform firstly together. If you go to next slide, you can see this figure. From this general view, we can find that the consistency of the gate signal is very good. They are almost completely overlapped. In this slide, we can see this detailed view in turn on and off process. There is some signal delay, but in 10 nanosecond, we would like to say it is acceptable. Now we know that the signal synchronization has no problem, then we can start checking the IGBT turn on and off characteristics. The steps are same to normal double pulse test, but we need to record the data from 6 IGBTs. Therefore, the time cost is quite high. An ideal way is that we can utilize automatic test equipment to process the test to increase our efficiency. Otherwise, we must record the data only one by one. In this case, Firstack has also test equipment. If you have interest in, I can also introduce it in the future. In this slide, I show this figure again to show how to read the data from the waveform. This is during on process, so it looks same like the figure in previous video, and this is during off process. If you have no idea what is this, please go back to our previous video. After checking the gate signal and IGBT characteristics, then we must test the current sharing performance. The steps are quite similar, I must say again, to VGE consistency test. We need to record the data waveform from 6 parallel modules, and in this slide you can see the overview of the test results. This is the current sharing of the 6 modules. In this slide, you can see that IC1 and 2 in left, and the right figure is for IC3 to 6. And this slide shows more details during the on process. There is one question is that how we evaluate the current sharing performance. Is there any quantification method? Normally, during the test, there are 2 ways to quantize it. The first way is shown in below expression. The current sharing criterion is equal I max minus I min. It's the maximum current minus minimum current, and then divide the average current. By this way, we can see here is criterion during the on process is 8.4%. Another method is that we don't use average current, but use load current. There is no exact definition of this current sharing criterion, but we can use these two methods as a reference for us to quantize the test result. Then in off process, we can also evaluate the current sharing criterion with the same method. It is 512 minus 500 and then divide 500, which is equal to 2.4%. After that, like in normal double pulse test, we need to evaluate then the reverse recovery characteristics of the diode. So we can go to next slide. The test process is also same. The figure is shown as a reference for you. So we can see that the static characteristic is relative worse than dynamic characteristics. The dynamic process is our on and off process, and the static process is the moment without switching action. So it is here. You can see this process. In this slide, there is a detailed view of the dynamic process. As we can see, the current sharing criterion is around 18.6%. So we can go to next slide. Here I make a table to summarize the data during the test. We can find that the diode consistency is worse than IGBT. In the end, I want to say for parallel operation, both GDU and the module are important. The GDU must send the synchronized switching command, and the module must have similar characteristics. Before we start parallel operation, sort the module is a critical step to ensure the system performance and reliability. The influence of the IGBT modules is not such significant, but for SiC, the silicon carbide module, non-sorted module can cause much worse current sharing and further influence the system dynamic performance. So from our test experiences, for SiC, we must sort the module first, otherwise your system will never be balanced. Okay, this is all content of our lecture. If you like our open course, don't forget to follow us. We will continuously share our product and technology in YouTube and LinkedIn. Thanks for your watching. Bye.